Dear students, welcome to the 6th sem electron. This is your 7th class on DSP. From the last 2 weeks, you have completed the basic operations performed on signals. That is operation performed on dependent variables and the operation performed on the independent variables. In the today's class, you are going to study the basic continuous time signals. In that basic continuous time signals, today you are going to complete what do you mean by unit step function, unit impulse function and the ramp function. In today's class, we are going to study the basic continuous time signal. We are having the different types of the basic continuous time signals. In today's class, we are going to complete what do you mean by unit step function, unit impulse function and the ramp function. Okay, begin first with the basic continuous time signal. In that you are going to study what do you mean by unit step function. Okay, so just you see here, unit is nothing but what? 1. Step is nothing but just you think that it is a 1 step ahead. Okay, so I will show you what do you mean by unit is nothing but 1 step is nothing but like this. Correct? Okay, that means this is a 1 step. This is 1 step. Okay, so 1 step. What do you mean by this unit step function? The unit step function is denoted as u of t. Okay, unit step function is denoted as u of t and it is defined as it is equal to 1 when t value is greater than 0. U of t is equal to 1 when t is greater than 0 and u of t is equal to 0 when t is less than 1. How you are going to define the unit step function? The unit step function is denoted as u of t. It is defined as the u of t value is equal to 1 when t is greater than 0 and this is equal to 0 when t is less than 0. Okay, in the next slide I will show the figure of this unit step function. Okay, and next when we are seeing this in the figure, what happens? The figure shows the unit step. In the next figure I will show you. But in that what happens? U of t is discontinuous at t is equal to 0. I will show you this. So okay, just what we are seeing in that means, so somewhat discontinuity is there in that u of t. So here what happens? So here you also see here what it is saying. For t is greater than 0, its value is equal to 1. T is less than 0, its value is 0. What about t is equal to 0? Correct. So that is why what is the thing means t is somewhat discontinuous. It is not equal to 1 or it is not equal to 0. So that to avoid this confusion, so let us once again define this u of t as u of t value is equal to 1 when you see here t is greater than or equal to 0 plus. Okay, and similarly its value is equal to 0 when t is less than or equal to minus 0 to the that means before minus and after, before 0, after 0. Okay, so you see in the definition what happens. Okay, first you see the Here you see this is the figure for the unit step function. Okay, first one is what your unit step function. Okay, this we will see after studying this. Afterwards, we will going to see this figure. First, you will see this one. What happens here? U of t is, this is what your u of t and this is what your t. This u of t is always equal to 1 when your t value is greater than 0. Okay? Greater than 0, then what happens? It is equal to 1. And in the next definition only we learned that if t value is equal to or greater than 0, then the u of t value is equal to 1 and its value is equal to 0 when t of value is 0 or less than 0. That okay, so this is what your representation of the unit step function. Okay, how you are going to remember? So unit is nothing but 1 and it is like a step. So that is why it is called a unit step function. This is for your remembrance. Okay. And now let us see what happens in the time shifting function. What happens when you apply the shift to this unit step function? Okay, similarly, the shifted unit step function is defined as, already we studied the time shifting. Okay, according to that, we have written that u of t plus t0 is equal to 1 when this t plus t0 is greater than 0, or you can say that t is greater than minus of t0. T plus t0 is less than 0 or t is less than minus of t0. The same thing is shown in this figure. Okay, so this t plus t0 when you are taking means it is called the time shifting property. Okay, if you have remembered that property, it's okay. Otherwise, you go and revise once again what is the time shifting property. Here what happens? Okay, today only I am explaining u of t plus t0 is equal to 1. This is your unit step function. U of t is nothing but only unit step function plus 0 is nothing but what? The shifted unit step function is equal to 1 when the t plus t0 is greater than 0. The same thing you can see here. So your function is u of t plus t0, whereas this is your t. Okay. So u of t plus t0 is equal to 1 when your t plus t0. So t plus t0 is nothing but how much? Or you can say that t is greater than minus of t0. So here minus is nothing but it should come here. So this is what your minus of t0. So this t plus t0 is equal to 1 till minus of t0. T should be greater than minus of t0 till that your t of t plus 0 is equal to 1. Okay, and after minus of t0, its value is equal to 0. Okay, this is what your time shifting unit step function. This is our simple unit step function. So the next here one example for the unit step function. The step function is used as building block to generate several discontinuous waveforms. An example of this effect is shown in figure. Where this step function is used? This is a building block to generate several discontinuous waveforms. Okay, more than one if you are having the discontinuous signals. In that, these step functions are used as a building blocks, or to generate the discontinuous signals. What happens using the step function? Okay, to generate the discontinuous signals, we are using the step function. So you see here, first one is what your one discontinuous waveform is there. So it is one x of t is a one signal. Okay, it has t0 and it has the amplitude is equal to 1. Okay, so just I want to discontinue this signal. What I should do for discontinuous signal? I have to apply the unit step function. What is unit step function? Unit step function is nothing but what? Here x1 of t is equal to 0 when t is greater than or equal to 0, and x1 of t is less than 0. x1 of t is equal to 0 when t is less than 0. The same thing is here. So here what happened? This is a one continuous signal is there. Okay, so here for this waveform just I have applied this. Okay, this is one discontinued waveform is there. So after applying the unit step, you are going to get this one, and this is what your shifted and inverted discontinuous inverted unit step function. What is this? This is a shifted and inverted unit step function. Okay, in the previous figure just only we studied the shifted. Shifted means what happens? This signal comes this side, but it is inverted. So just I want to show you the another example. Okay, so here what happens? It comes below, then it is called the inverted unit step function. So totally what happens? X of t is nothing but totally this x of t is actually x of t is a one discontinuous waveform signal. This is equal to x1 of t plus x2 of t. So x1 of t is a unit function, that is u of t, minus what is your x of x2 of t? That is u of t minus t0. Okay, here what you will get? You will get t minus t0. So now let us move to the second one, that is unit impulse function. Okay, next second one is unit impulse function. The continuous time unit impulse function is defined as delta t is equal to 0 when t is not equal to 0. Okay, so first thing is this unit impulse function is denoted as delta t. Okay, it can be defined as this delta t is equal to 0 when t is not equal to 0. And let us take this as first equation. And next one is minus infinity to plus infinity of delta t. That means when you are taking the integration of this, then its value is equal to 1. This is the second equation. Okay, by combining this, we can write that delta t is equal to delta of minus t. But what happens? Delta t is an even function. Okay, delta t is an even function, and next what happens? This is what your representation of the unit impulse function. Okay, in this representation, usually arrow is nothing but what we are representing. We are representing this arrow is nothing but it is an amplitude. But in the unit impulse function, you don't think that it is an amplitude, it is area under pulse. Okay, in the unit impulse function, it is area under pulse. From the impulse function, it can be visualized that impulse as a tall, narrow, rectangular pulse of the unit area as shown in figure T. Okay, so from this what happens, we can say that it is a one rectangular pulse. Okay, so what it is looking like a one narrow and tall, and it has the area, that is its area is 1 unit. Okay, and so this is what your figure for the unit impulse function. In the next figure, we want to show that the height is very large, the width of the rectangular pulse is very small, that is t tends to 0, and the unit impulse is therefore can be regarded as a rectangular pulse with a width that has become infinitesimally small and height that has become large, maintaining the overall area at unity. Okay, the same thing is in the next figure. In actually this approximation of unit impulse by rectangular pulse. Actually here what I have taken, area is equal to 1. Okay, this is nothing but what the area. Okay, here what happens, t tends to 0. Totally t tends to 0. You see here. Delta t is equal to limit of t tends to 0 g of t. So this is the approximation of the unit impulse by the rectangular pulse. The width of the rectangular pulse is very small. Why? Because that is t tends to 0. Its height is very large. Here you see when t tends to 0 means what happens, 1 by t. This is what your 1 by t. If this tends to 0, anything by 0 is nothing but actually you should get a one big value. So that is why we have written as its height is very large. The unit impulse therefore can be regarded as a rectangular pulse with a width that has become infinitesimally small and a height that has become infinitely large, maintaining the overall area at unity. That means what? Always it maintains the area should be unity, whatever may be the height. Here the height is very large. It may be the infinite also, because anything by 0 is nothing but the infinity. Okay. So actually what happens here, the some properties of the impulse function is given. So here just I will tell you little bit about this. Please try to read this. So one is the product property is there. Here the what happens, delta t is a one function, and that is multiplied by phi of t. Then what you are going to get, this is the what your product property is there, and this is the shifting property of the unit impulse function. Okay, just now what we have studied about that step function, no, using the same concept they have written the shifting property. Please go through this and note down in your. Okay, this is what the time scaling property, that also we studied in the properties of the signals. Okay, please go through this and note down in your notebook. So here we have the another one. So actually this is a one proof for the time shifting property there. So another one important function is the ramp function. Okay, ramp is nothing but all of you know here in the figure also I shown. This is called what? The ramp. Okay. So here let us see what is the definition for this ramp function. This ramp function is denoted as R of t. Okay. So till now we have studied the step function and the impulse function. According to that, the ramp function is defined as, here you see, the unit step function is the integral of a unit impulse function with respect to time. Okay, unit step function is the integral of the unit impulse function with respect to time. By the same token, the integral of the step function, that is u of t, is a ramp function of the unit slope. Mathematically, a ramp function is defined as that is equal to t value when t is greater than or equal to 0. Okay, and its value is equal to 0 when t is less than 0. Okay, here you see this is what your r of t, and this is what your t. Okay, your r of t value is equal to t when t is greater than 0. You see here, t is greater than 0 is nothing but this quadrant. Okay, always this r of t value is equal to t value. That means what? If t is equal to 0, r of t is also equal to 0. If t is equal to 1, r of t is also equal to 1. So here you are keeping the point. Similarly for the 2, you are going to here you are putting the point. Like that 3. So 4. So that is why what happens, you see slope you are going to get the unity. So when combining this you are going to get the ramp. So that is why it is called a ramp function. Okay. And next one is what? Its value is equal to 0. That means r of t value is equal to always 0 when t is less than 0. Less than 0 is nothing but it comes in the negative quadrant. In the negative quadrant, what happens? Whatever may be the your t value, rt value is equal to 0. Just you see here, t value is increasing, but r of t is equal to 0 only. Okay. So what do you mean by the ramp function? Means ramp function, as just how you can remember, this is what your ramp wave. So okay, so whenever you are getting this slope like this and like this you are getting, this is called the ramp wave. Depends on that, just you try to remember the ramp function. It is denoted as r of t. Its value is equal to t when t is greater than or equal to 0, and its value is equal to 0 when t is less than 0. So finally, we can write this r of t is equal to t into u of t. What is your u of t? U of t is your unit step function. Okay, unit step function multiplied with the t, you are going to get the unit ramp function. Okay. Let us hope all of you understood these concepts. If you have any doubts, put the doubts in the Telegram group. Okay, these are the reference books. If you want, you can download this book from the net. Okay, meet in the next video.